Hey everyone, and welcome to the video. Today I'll be showing you how to implement the state-of-the-art object detection system, YOLOv4, in the latest version of TensorFlow 2, as well as TensorFlow Lite, which is perfect for mobile and edge devices such as Raspberry Pis. And finally, I'll be showing you how to implement YOLOv4 with TensorRT, a highly optimized inference method for deep learning. I will cover how to convert the YOLOv4 standard Darknet style weights into saved TensorFlow models. Then we will step through together how to run and save YOLOv4 detections on images, videos, and webcams for standard TensorFlow, TF Lite, and TensorRT models. As always, I hope you guys enjoy the video, and if you do, please hit that like button as it helps my channel grow. And if you are new to the channel or want to stay up to date with all my future YOLOv4 videos, then please smash that subscribe button. Let's jump right into the tutorial. Okay, we're going to jump right into it. So first things first, as always, we need to get the code for this tutorial. And before we do that, I want to give a huge shout out to HungLC007, as he was the one who did the majority of this code, and I forked it from his repository and then made the adjustments. So kudos to him. So to get the code, we're going to go to my GitHub repository, the AI guys code, and then you're going to go to the repository TensorFlow-YOLOv4-TF Lite, and I'll leave a link in the description to the GitHub repository to make it easier for you guys. And then you're going to go ahead and click the green button that says code, and you're just going to click this little icon if you're going to do a git clone. If you want to just download the entire folder and files, you can just download the zip, but I recommend, as you'll see that I do, git clone. So you're just going to run the command git clone, and then you're just going to go ahead and paste that link right in there, and that's going to go ahead and clone the entire repository for you. And it's going to take a little while as it's quite a big repository, so I'll come back when it's finished. So once it's finished cloning, you can just go cd TensorFlow, hit tab, and then head into the repository. And if you want to look around at the code, you just do code dot. If you have VS Code downloaded, which I recommend, and you can then go and look through the code as you see fit before starting the tutorial. Just look around and start to understand things if you want. Otherwise, if you're following along, we're just going to go right ahead with it. So the GitHub repository has a pretty in-depth README that I'll be following along for the video. If for any reason I go a little too fast or something's not sure and you're stuck, refer back to the README here as it goes through all of it in depth. So if I miss anything and you have any errors, check it out here. So first and foremost, we have to go ahead and get all the required dependencies to run the code for YOLOv4 in TensorFlow. There's two different ways of doing this. An Anaconda way, which I recommend, and just pip installing, just straight pip installing. And then there's also the configuration for CPU, if you're just running it purely on your CPU, or if you have a GPU on your laptop or desktop, you can run TensorFlow GPU, and it'll actually accelerate the speed in which the object detector does the detections. So I recommend if you have a GPU to use it. And you're going to see that I'm going to use the Anaconda route because for GPU, it actually helps integrate all the CUDA toolkits and stuff in the environment for you. So if you're doing the pip install with GPU, then you're going to have to make sure you have all the NVIDIA drivers and toolkits properly set up on your machine. But if you use the Anaconda route, which I recommend you have, or if you don't have it already, go download Anaconda, as it'll help a lot with setting up the GPU. So we're going to go ahead and run these commands for GPU. Once again, if you don't have GPU, you can run the CPU ones and it'll work. Everything will work just fine. So we're going to go ahead and copy this first command right here and then go back to our shell and just paste it in. This is going to go ahead and within the code, it's going to copy all the requirements from whichever YAML file you specify. So I'm doing the GPU. If you're doing CPU, it would just go ahead and download all of these requirements. So it's pretty straightforward. It's going to take a couple seconds here to set up the environment. I'll come back when it's finished. Once the Anaconda environment is done setting up all the dependencies, it'll prompt you like so on screen. And then to go ahead and actually activate the Conda environment, you just go Conda activate. and then the name of the environment, which is YOLOv4-GPU or -CPU if you did CPU. So you go ahead and run that, and now you have all the dependencies set up. And once again, if you did it with pip, you wouldn't have to do any of those Conda commands. So there's the two ways. So now we can jump right into it. We're going to want to go ahead and download the pre-trained YOLOv4 model. This model is trained on over 80 types of classes or objects that it can detect, and is really strong out-of-the-box model that is pre-trained, so why not use it just to see if everything's working correctly. So you're going to go ahead and click this link to download YOLOv4.weights model file, which we will then convert into TensorFlow or TensorFlow Lite or TensorRT. So click the link, it'll download. I already have it downloaded. So we're going to go to my downloads, see YOLOv4.weights, and then you're just going to copy it, Control-C, and then you're going to go back into the code of the repository, TensorFlow YOLOv4 TF Lite, wherever you cloned it, and you're going to paste the weights file into this data folder. So go to the data folder and Control-V and paste it in here. So that's what you're going to have to do in order to set up the weights properly. And then if you want, there's a way to use custom trained YOLOv4 weights in TensorFlow, but I'm going to save that for a future video, but it is here for reference if you want to jump ahead, but check back later for how to do that in a future video. So just using YOLOv4, implementing it in just normal TensorFlow .pb model file is the first step. So you're going to want to go ahead and run this command for saving the model and converting it from the YOLOv4.weights into your .pb model file. So you're going to go back to your shell and run this and just paste it in, and it's going to go ahead and run. So it's Python save model.py --weights, the weights flag, and it points to your weights. So if you did save your weights somewhere else, you can still run this by pointing to the proper path to your weights. And then it outputs, this is what you're going to call the model. So it's going to be called YOLOv4 -416 because we've set the input size to 416 for the model, because that's what I trained my model to generically be on, or that's what the pre-trained YOLOv4 is trained on, 416 by 416 image size. And then -- model flag points to YOLOv4. So you actually can run all of these commands with YOLO version 3 weights if you just did -- model YOLOv3. So this still works for YOLO version 3 if you're still using that version. So this is going to go ahead and do everything, pretty much convert all of the darknet into TensorFlow. So it's pretty much doing a one-to-one conversion, and then it's going to, at the end, save it as the TensorFlow model file, which is pretty sweet. Just in one command, it does all of that. And once again, you can go to the code and check out what the save model.py file is actually doing if you're curious. So if the command went as planned, it should look something like this. You should see the parameters, trainable params, and non-trainable params. And if you go into the actual code and you look in the checkpoints folder, you should see this saved model.pb, and it's going to be called what we named it, YOLOv4 -416. So it's correct. It looks like it has correctly converted from the YOLOv4 weights into the TensorFlow model file. So we're going to go back, and you can actually do all of these commands with YOLOv4 Tiny if you're running a YOLOv4 Tiny model, and you can download the weights up here as well. So I just wanted to point that out before we move on. So now we're going to actually go ahead and run our detector. So you're going to go and grab the command for run YOLOv4 TensorFlow model. Just copy it and head back to the command line and paste it in there. So there's two different ways you can run. You can run detect.py in the code, which runs on images. And you can also run on video using the detect_video.py files. So it works for both. And detect video also works for webcam, which I'll show you. But let's go back and actually check out the flags for this command, detect.py. So it's Python detect.py. The weights point to now you point to your TensorFlow weights. So just the folder, YOLOv4 416, size 416, model, and then this is the new command --images, which you can actually do a string, comma separated string, and have it run multiple images all at once. This image that it's pointing to in the images folder, let's go check it out in the code. So we go to data, images, and there's two images that you can actually come with the repository that you can try the model on. So dog.jpg and kite.jpg, and we just did it on kite. So it looks like we have successfully ran our model, our YOLOv4 implemented in TensorFlow. As we can see, detections and confidence values on screen. So it's properly detected kites, a bunch of kites on the beach image, and as well all these people within the image. So you can see that it looks like it's working. You can try it out on any types of image you want. Just go ahead and upload your own image into that images folder and run it however you want. And so one thing to point out, after you run the model, it will automatically save the detections for however many images you run it on in this detections folder that's in the root folder of the repository. So just go to detections and detections 1. If there was multiple images at once, it'd be detections 2. So I'll show you guys that you can run it on several at once. So to run on multiple images in one command, like I said, it's a comma separated list. So you're just going to add quotations around the images flag at the end of the command, add a comma, and then the path to the second image. So there's also this dog.jpg within the repository. So we're going to go ahead and run it on both of these images. And then we will see that they both get saved to the detections folder. So it's pretty neat, pretty nifty. And TensorFlow is extremely powerful, which is a huge perk. And as you'll see in a couple of minutes, we will be able to actually convert into a TensorFlow Lite model and be able to actually hopefully run the model on mobile or edge devices. So here's the first image. There's the second image. And if we run back into the code and go to the detections folder, we now have two images, the one with dog, bicycle, and truck, and then the people and the kite. So next up, let's run it on video. So we're going to run our YOLOv4 implemented in TensorFlow on video. So we're going to copy this command right here that says run YOLOv4 on video, and it points to that, like I said, that second script detect video.py. So we're going to go ahead and just paste it in, and I'll look over the parameters here with you. So let's expand this, and if we go ahead and scroll back up, it's almost the exact same command. So it does the weights, the size, the model, and now the flag is -- video, and you point to the video. This video.mp4 is in the repository already, so this should work for you if you run it. And then there's this output flag. If you want to save the results of the video, you run this output flag. If you don't set it, then it just won't save the video with the detections overlaid on top. It's perfectly fine. So we're going to want to save it. So we're going -- output, and then you just point to where you want to save the file. So in the detections folder that all the images were saved in, and we call it results.avi. So we can see it running here. And then you should see, if we scroll down in the console window, in your command prompt, it's actually going to be outputting the FPS that it's getting on the video. So you can see that since I'm running it TensorFlow GPU, I'm getting fairly decent FPS rates. I don't have the strongest of GPUs, but I have a moderate one. So I'm getting around 15 frames per second, whereas live video is usually around 30 frames. So it's not bad for a moderate GPU. If you're running this on CPU, you'll probably get around 4 to 8 frames per second, depending on the strength of your CPU. So yeah, GPU will at least double that frame rate. So once it's finished, like I said, if we go into the detections folder, we should now see that we have this results.avi video that will play back in full speed. So we can see that it's doing a pretty amazing job of implementing YOLO or TensorFlow on this video. As we can see, it's getting a lot of detections: handbag, car, bicycle, and people walking on a busy street. So once again, it just shows the strength of YOLOv4, and pretty cool that we can implement it on TensorFlow. So let's head back now, and we're going to try it on webcam. So due to my screen recording having access to my webcam, I wasn't actually able to run the command recorded for you guys, but I have ran it here and show you that it works correctly. So we have the exact same command, setting video to 0, and it goes ahead and runs successfully with a frame rate around the same as the other video, around 15 frames per second. And if I head here into my detections folder, you can now see that it saved the new video of my webcam, and it's seeing my person's detects me, and it detects my phone. So you can see that it does indeed work on webcam if you run that command. So I suggest trying it out. So that's pretty much it for the TensorFlow, straight TensorFlow.pb save models. But now let's get on to the TensorFlow Lite version. So these are just some demos here. And so we can actually run TensorFlow Lite. And what this allows us to do is convert YOLOv4 into .tf file. And TensorFlow Lite, if you don't know, is much smaller model size than regular TensorFlow, which allows it to be perfect for integrating with mobile devices or IoT edge devices, such as like a Raspberry Pi or a Jetson Nano. So if you're interested in running either an Android application or on a Raspberry Pi, this is going to be the route you're going to want to go. So yeah, let's get right into it. So you're going to run this model, the save model.py script right here. So we're going to go ahead and copy that, throw it into our command shell, and then just paste it in. And this is actually going to go, so the difference between this one and the save model.py for the regular TensorFlow is that at the end, there's an extra flag, -- framework, TF Lite, which allows you to know that it should be converting, getting it ready for a TensorFlow Lite model. And then there's going to be one extra step here that we're going to run after this one successfully completes, which is convert TF Lite. So this actually takes the model created and converts it down into the smaller size. So this saves the model as almost a regular TensorFlow, and then this is the one that actually converts it into that smaller TF Lite. So once the save model command is finished running, you're just going to go ahead and paste in the convert TF Lite, and that's just going to go ahead now and, as I said, convert it into the smaller model size. And there's actually multiple different versions of TF Lite that you can use. So there's actually 3 separate commands here, converting to a normal TF Lite file, to the quantize float 16, and to the quantize int 8. All of these have different strengths and different abilities to be either faster or smaller size. So I recommend, if you're new, just using the regular TF Lite. But if you're an expert at TensorFlow and TF Lite and specific use case you have in mind, then I would definitely recommend checking out these 2 different other types and figuring out which one is best for you or which one will work for you. So there are different models that you can run it on. So then once it's done converting, we're just going to go ahead and run the exact same TF Lite detect.py script. And then we're going to do it on the kite image again. And then once again, all you add is that framework TF Lite flag to let it know that it is indeed running the TF Lite version within the code. Because if you actually go in and look, there are some sections of the code that say, if framework is TF Lite, save the model as this and run the model in a different way. So you have to make sure you have that flag set if you're running it on TF Lite. So we're now just going to go ahead and paste in the detect command and let it run. So it's going to be running YOLOv4 implemented in TensorFlow Lite once again, which is perfect for mobile or edge devices. So you can see that it ran perfectly, exact same as the regular TensorFlow, but it's a little bit faster and more lightweight. And if we actually head back in this repository that the original owner, Hung LC007, he actually has some Android code in here. So if you're looking to run this on Android, I recommend playing around with that. And I will be having a video in the future where I run it in an Android application. But if you want to jump ahead and get a head start, there is code in here. So we've now successfully ran our TF Lite model, and we can see that we had the good resulting image, just like the previous one. So last but not least, the strongest of the bunch is actually TensorFlow TensorRT. So what TensorRT is, it's a high performance inference optimizer meant for these deep learning and AI applications. So they're created specifically for AI and deep learning, so that they are optimized for doing such commands. So TensorRT can allow up to 8 times higher performance than the regular TensorFlow, whereas the TF Lite is around between 3 to 6 times better than the TensorFlow regular version. But TensorRT is up to 8 times higher performance, which is crazy. You actually do need a high-end GPU, like the Tesla or stuff like a higher version like that, to actually run TensorRT. So my GPU on my laptop here isn't actually strong enough to run TensorRT. But if you do have an extremely strong GPU and you've been looking to implement YOLO using TensorRT, I would recommend just following these commands as you see fit. So one more thing I want to show you guys before we finish off this video is all these command line arguments. So if you're struggling with the flags for all of the commands, the save model, detect, as well as the detect video, I've listed them all here. So there are a few I actually didn't really show, which is IOU, which you can change the IOU threshold or how close things have to be, different detections in order to signify them as one single detection. So it might detect a person twice, very close, but they overlap. So it merges them to the proper one detection, as well as this flag for score, which allows you to change the confidence threshold that you want to display back on the image. So it's set right now to 25%. So the model has to be at least 25% confident in its detection that it's a person in order to display it. But if you just do --score 0.50, you can up it to 50, 60, 70. So depending on your preference or what you want the model to expect, you can change that as you see fit. So that's really it for this video. I hope you guys enjoyed implementing YOLOv4 in TensorFlow, TensorFlow Lite, and TensorRT. So if you enjoyed the video, please smash the like button and subscribe to the channel to make sure you catch up on when I release the Android video, as well as using the custom model in TensorFlow. So see you next time.